You've probably seen people create cool things with vanilla shaders like this, right? Or you can find a bunch of posts in a bunch of Discord servers like this, which is fully in vanilla Minecraft resource packs. And you want to know how to make your own. First things first, before you do anything, you want to go into settings and you want to enable output log when Minecraft Java starts. So then you launch Java. Before you know anything, you have to know the concept of what a shader is, right? So there are two kinds of shaders that you can edit in Minecraft. There are vertex shaders, fragment shaders. Alright, so vertex shaders, they're just shaders that they just create the meshes in the world. Like they create the triangles and faces in the world and stuff, right? That's all you have to know. It's a bit more complicated than that, but that's all you have to know for now. And what fragment shaders do is they go per individual pixel and run the same exact piece of code for each pixel. And that's how we color our triangles. So let's say we want to do some texture mapping. We have our texture, let's say it's like stone.png. And how do we get this texture to be warped onto that face? We do it with UV coordinates. So we assign each coordinate to each vertex. So for example, it's going to be 1, 0, 0, 0, and 0, 1. And then we assign the same thing to these corners. And then we just interpolate to get a pixel inside of the texture. And then we just map each pixel to each pixel on the face. And that's how we texture map. And to get information between these two kinds of shaders, so when you define a fragment shader, it's going to be called .fish. That's like the file that gets read. And the vertex shader is .vush with a V. And the vertex shader gets run for each vertex, and for inside the face, each fragment shader gets run. And to pass things from the vertex shader to the fragment shader, you use out qualifiers. So let's say you want to out the UV coordinates. You put that in your code. And you want it in the UV coordinates that you passed out. Use in back to UV. And in Minecraft, we are given two shaders that we can edit. There are core shaders, which are pretty new. And there are post shaders, which we could edit for a while. And core shaders edit the things within the game. Like, let's say, solid blocks. Or let's say, like, the sun. The sky. It's like things within the game. Entities. Like, that's how they get rendered. As you can see, let me go in the default Minecraft. We go in the shaders. We press core. There are all these different render types. So, like, let's go to solid blocks, which are these three. There's the fragment shader, JSON, and vertex shader. If we can peek at the fragment shader, it's taking the sampler is the Minecraft texture atlas, and text coord is the UV coordinates. It's taking the texture, multiplying by its vertex color, which is like lighting, and color modulator, which I have no idea what that is. And then we do the fog effect. And post shaders, you know when you have a creeper, right? And you spectate it, it transforms the whole screen. See, what it does here, it turns it green and pixelates it a bunch, right? So that's a post shader. They're like a bunch of little programs. They're defined as programs in the code, which are these. Most of them run in specific things, like spectating a creeper is a post shader. And you can actually edit that code, which is in bits is the first one. And then there was a different one that does I think it's this one, color convolve, that does the green effect. They're two different programs that get run. They do it on the whole entire screen buffer. Buffers are just like images. Like they transform the whole buffer and spit out the green version, right? And they also run when spectating a Enderman or spider or stuff like that. Most of the things in the game are when you spectate things. And in old versions of the game, you might have heard of something called super secret settings, which make your game look all weird. Those are also post shaders. But if you want a post shader that you can do all the time, that runs constantly. There's a special one. It's called if I can spell, transparency. And transparency is very special because we don't have to spectate anything for it to run. As you can see, transparency.json. These are all the other ones. So blur, I assume it's like this thing, as you see the background. Creeper is the creeper. Entity outline, I assume that's like the glowing effect. Yeah, I assume it's this effect that gets run. Invert is like, actually don't know. Spider is the spider effect. And transparency is the one that gets run on all times, but you need the fabulous graphics setting. And both of those, core and post shaders, each of themselves have fragment and vertex shaders. Remember, fragment runs for every pixel on screen within the face or triangle, and vertex shader is how they get the faces. Now that's the concept. Now how do we get to actually editing them? So first I'm just gonna copy 1.21 default resource pack assets, but only the shaders part. But I already did that because this is not my first attempt at recording this. So it's just in shaders, and let's try editing the core shaders first. If we want to know which specific thing we want to edit, like let's say grass blocks or specifically dirt blocks, well, you can't. There are only specific types of things you can edit, like creepers or like entities or like solid blocks, right? Or like the sky color. Like those are different kinds of shaders. So like let's say we want to edit all the solid blocks, which surprisingly aren't grass blocks. Stone and dirt are definitely solid blocks. So let's say we want to edit solid blocks. There's this document that shows you what each render type file in the default packs actually edit. So like crumbling will edit the block destroying effect. So let's go in the default Minecraft resource pack. Go in the core shaders, and we have all these different render types. So let's find the one we want to edit, which is solid blocks. I already know it's solid, so let me find solid. It's these ones. Let me copy these and then put them in my own pack. Alright, and let's say we want to edit the fragment shader first. So instead of whatever this color is, which is doing a bunch of transformations, we just set the frag color to be pitch red, like perfect red. And then we try running the game with that. We turn our pack on. As you can see, every single solid block is now rendered as red. It doesn't have to be red, I just did that right now. It can be a mix of red and green, which as you might know, it's yellow. You can do a bunch of cool stuff. In the vertex shader, as you can see, GL position is the position of the triangle on the screen. Of course, it doesn't do 3D for us, so we need to multiply it by the projection matrix and the orientation matrix by our actual thing in the world. So for example, let's say we do not multiply the orientation matrix, which in Minecraft is called model view map. Let's say we don't multiply it by that. So what that'll effectively do is make us look forward only for solid blocks all the time. Here, I'll show you. By the way, it's F3T to reload resource packs. As you can see, no matter how much we move around right now, the solid blocks stay stationary. All the other blocks get moved around as accordingly because we're not editing them, obviously. But solid blocks, we change them so that they don't get multiplied by any view matrix, so we can't really rotate ourselves. But we can move around, obviously, because that's just displacement. So yeah, you can do a bunch of things with GL position. And the JSON, you don't really have to worry about that, at least for the core shaders, you don't have to worry about that. So post shaders get defined in shader/post, but the actual functions are in program. So let me copy both. Include, you don't have to worry about that. It's just like default functions that in case like Minecraft doesn't want to reuse them a bunch. It's like fog and stuff. Who cares about that? Let's make 2 new files and make sure we turn on fabulous. Oh, whoops, I forgot to add back the fucking... Okay, let's just multiply. Okay, that should work. I expect that you know a little bit of GLSL. These are all GLSL files. They're just called differently, like fush and fush. Okay, so let's go back to post shaders. delete everything except transparency. And if we look inside here, you're like, what the? Fear not. I'll show you how everything works. So these are things called passes. So what passes are, you can define a bunch of different buffers in Minecraft post shaders. And what passes are is like, it defines how to communicate with them. Let's say you want buffer A to pass to buffer B and buffer B to pass to buffer C. You have to define that in the code with in targets and out targets. So for each buffer, they have an in target, which for A, let's say it's taking that from the default Minecraft scene, which is the whole screen, which is actually in the code called Minecraft main. The in targets for that would be Minecraft main, but the out targets would be B because it's sending its own buffer to B. And for B, the in target would be A and the out target would be C. You see what I mean? How I get it? So for the transparency, which does a bunch of shader stuff that we don't care about because we want to edit them. If you see what these do, the first one's called transparency, which is the shader it runs. The program shader it runs, which is transparency.fish. The in target will be Minecraft main, which is the default scene, and the out target will be final. And these aux targets are just like the bunch of samplers it can use. Like, I don't really touch any of them. Sometimes you might need the depth sampler for if you want a depth map. And in the second pass, the program is called blit, and the in target is final, and the out target is Minecraft.main. So what it's doing is, we have Minecraft main, and we have final buffer. So what we're doing is, we take Minecraft main, put it in the final buffer, while running the transparency program. And then after that, we run it back to the main buffer with the blit program. What blit does, it just copies buffers. As you can see, blit, it just copies a buffer. So let's actually delete everything except blit. Texture diffuse sampler is just how we can get the in targets color data. As you can see, we uniform sampler 2D, diffuse sampler. Instead of writing it back to Minecraft main, let's make our own shader in here. Let's call it custom, which in target, let's make a new buffer and call it new buffer. And instead of outputting to Minecraft main, we output to new buffer. Now our custom will write to the Minecraft main buffer, which is what we see at the end. So now let's make a program called custom. So in the JSON, you can edit this blend thing. I have no idea what it does, I'm gonna be honest. What's important is that you change what programs it's reading in here, which is not blit, it's actually custom. For the vertex and fragment, we're editing both. You might be like, why do post shaders have a vertex shader? I don't know. It's like the whole screen. It's like from here to here to here to here. And the default sampler will be called diffuse sampler. That's how we access the game. Let's say we want to edit something, right? Let's say we want the frag color to equal, again, red. Please don't crash, bro. And it crashed. Now when it crashes, we look in the game log, find what happened. Output target new buffer does not, see, we did not define the buffer in here. We have to define our new buffer. As a target. So now let's add back our resource pack. And it disables fabulous as well. And as you can see, the whole screen gets red. So let's say we want to mess with the texture coordinates. So let's just plug in texture coordinates for the first two parameters. Let's see where that takes us. As you can see, it's literally what you expect. And let's say you want to do a bunch of cool things like vec2 uv equals text coordinate times 2 minus 1. Now it did that, put it in the center. And then we do vec4 col vec4 1.0. Let's do a conditional. So if length of uv is greater than some radius, which is 0.5, that. Otherwise we do that. This is just like, it's like kind of like C++. So if we try displaying that, I'm kind of an idiot and forgot to display the color bar. And now we have a circle. But what if you wanted to overlay the circle onto the Minecraft buffer? Well, we can use the alpha channel to help us, right? So we have our color and we have the default. Let's actually define a default sampler. Okay, for default, default's a thing. Def equals texture, diffuse sampler, and text void. Now we have our color and the default one. And we want to blend between the colors alpha, which is either 0 or 1, depending if it's in the circle. So we just do lerp between col, def, and col.a, which is the alpha. Crashed. Line 17, OpenGL does not have lerp. Oh yeah, I'm an idiot. It's not lerp, it's mix. Oh, as you can see, we did it backwards, but we're getting somewhere. So it's actually def col.a. So let's try re-enabling that. And now we have a circle on top of our screen at all times. But we also render the Minecraft buffer if it's outside of the circle. And you could do a lot of cool things with this. And also, something to keep in mind, when you pass buffers, they get passed as 32 bits for 8 bits for each color channel. And it sucks ass, but there are workarounds that we have if you ever want to pass more than that. But you'll have to stay tuned for that, I guess, because I don't want to do that in this video. I'm going to explain what 32 bits means though. When you pass them like this, these are 2 passes, the buffers only get passed as 32 bits RGBA. Okay, I actually cannot write 32-bit RGBA buffers. Actually, I think people will call it 8-bit RGBA buffers because it's 8 bits. 8 plus 8 plus 8 plus 8 is 32. So what that means is for each color, we have one really long, let's imagine it as one really long 32 bits. Bits are just ones and zeros. And we divide that into 4, which is the RGBA. So these are 4 bytes, which are 8 bits. So like 1, 2, 3, 4, 5, 6, 7, 8, 32 times. If you want to encode data, you can store them as 32-bit numbers, floating point numbers, because that's even better. And if you want to do something like this, it's just a ray tracer overlaid on Minecraft. But as you can see, we somehow edited the ray tracer position and direction and focal length to be with Minecraft, right? Like, how did we get the orientation matrix in the post shaders? You can't. You literally can't. That's only in the core shaders, the model view matrix. So what I did specifically, there are many different ways to work around this. I effectively passed a core shader to a post shader, and this is not supported. You have to do a bunch of magic fuckery to pass core shaders to post shaders.